Afternoon session, we have been completing our practice session now based on common emitter and common source. I think I have written 2-3 slides already. I have written some content for you, short notes. First, complete the short notes. Just I'll give the overview. Please note on it first. The first content I have given in the board is short notes. First, I have written highlights for you. First, I started. Just 1 minute. Afternoon session, we have been completing our practice session now based on. So first session, I have given some highlights for you in the board. That is hybrid parameter model diagram. We have seen already 4 parameters. One is a HIE, one is HRE, one is HFE and HYE. In common emitter model, generally we try to practice most of the times in hybrid theory. These 4 formulas you should have a practice. Standard things I'm writing in the board. These 4 formulas you should have practice. In previous class we derived it. Just now we should have a highlights now. The current gain in exact model theory we have is minus HFE by 1 plus HYE into RL. That's the first formula. Please note down and listen to the class. And input impedance is not HIE in exact model. Yeah, Divya, I'll tell you. Schedule for tomorrow is changing. I'll tell you the timing also. First, note on the points. Current gain, input impedance, HIE plus HRE into AI into R. That's the input impedance in exact model we got. The practice you must have. And voltage gain formula is current gain into load resistance by input impedance. That's the formula. And the last formula we have seen is Z0 1 by HYE minus HRE HFE by HIE plus RS. The only thing is these 4 formulas you should have practice of the total content. Okay. After understanding these formulas, we enter into the approximate model of common emitters. I said 99% the questions will be an approximate. So approximate model have only 2 parameters. One is HIE and one is HFE. HRE and HYE are neglected in the class. Okay. So EI formula I have written only minus HFE. This term I have neglected HYE into RL. And input impedance I have written only HIE. HRE is neglected. And AV formula is A RL by ZI. The formula became very simple like this. Minus HFE into RL divided by HI. And here Z0 is HOE, HRE should be neglected. So 1 by 0 if you do, that will become infinite. So this is the first content you write in your notes. This is about hybrid parameter formulas, which is required for doing the problems. So main content try to keep in mind. Yeah, Partha, you can tell in the last slide FH. What is your doubt? You can post me. I'll answer your question. So first slide you complete it. Write very fastly here. Quickly write down. So the problems have to start. This is about your first theory. Okay. So Ankumdas is asking a small doubt. Just I'll clarify your doubt. Just we'll go back. In this models, which is your highest, which is your lowest? If anybody asks me, I'll give the preference for this. This will become your FL. You can write down in the notes because it is having the lowest resistance called 1 by GM. Whenever you have lowest resistance, it will give the highest frequency. And in this 2, which is the lowest one, that will become your FH. So your first time constant will become your FH. So FH1, FH2, we are considering the input frequency, input time constant here. Here we are considering C. These are your FLs and FH. We are designing the subject. Okay. So please note on it. So this is about your first slide, which we completed. The second slide, you can see, this is the second slide. We just copied second slide, which is RE model, and one is RPi model. I have written concepts. RE model and RPi model. Swati, nothing to memorize. When you are doing problems in workbook, definitely you will apply that formulas, correct? Then automatically it will be remembered in your practice. Okay? Only 4 formulas. Other than that, they are not formulas. They are only basics of diagrams. Diagrams are NI formulas. Only the first exact formulas. One time you can recollect. The remaining things will come from that only. They will generate it. Only 4 formulas you have to practice. Other than that, everything will come directly. And Parthasarthi, you are asking, see out why CT is coming. The CT is between collector and base. Previous slide, somebody is missing. Jaldi khatam karo. Divya Das, Parthasarthi, for you, meanwhile, I am telling you, why CD? Why CD? I have written C0 as CD. What is the logic for that is? You have the formula here is CD divided by 1 minus 1 by AV. This is actually Miller's output capacitance. Correct? CD into 1 minus 1 by AV you will get. Maybe I think you'll get in numerator when you talk about capacitance. You'll get like this 1 by 1 minus AV. You'll get like this. What I have done the approximation is, the gain is very high for BJT amplifiers. BJTs were getting more gain. That's why I just neglected it. The answer became CD. So we done some approximation there that 1 by AV is there. Voltage gain is very high in BJT classes because we are getting around 10 power 3, 600, 1000 like that. We are getting voltage gain in common emitters. That's why if you neglect this answer, it will become CD. That's why C0 is equal to CD I have written in the classes. Yeah. Correct, Parthasarthi? Correct. So I'm expecting the next slide. You know, this is the next slide. Okay. In this slide, I'm teaching about RE model. This is RE model. Input side we write beta RE, 1 plus beta actually. You can write as approximately beta RE. In this side we have written beta IB. So HIE of two-port network theory can also be written as beta RE. Input impedance we can write equal. HFE times IB we can write as beta IB. RE formula is coming from the diode small signal theory. It is VT by IEQ actually. IEQ or ICQ you can take same. Approximately both are same. GM is a reverse to dynamic resistance I proved already in my class. These are the basic formulas we have to keep in practice. Okay. Very small formulas there. They are very small formulas we can see. Yes, Neha Kumari, that's why I came side. You can see the screen, proto screen. So, and not only this is Y model I said, not only this there are T models also in our presentation. Okay, whenever you want T model for common base transistors, T models are better, you can use these models. Okay, T model also we can do it. Base side if you want, beta you write. Emitter side if you want, input resistance you write as small r. And coming to RPi model, in place of input we are writing RPi. Current source we have represented as GM into VPi. And the relations we found is RPi can be called as beta R of RE theory and HIE of your hybrid theory. And RPi can also be written as beta by GM you can write. So RE को हम लिख सकते हैं 1 by GM. So beta by GM you can write. And IB current, base current is nothing but V pi by R pi. These are the very basic calculations and links we must have a practice. Nothing more than that we want. So this is my second slide. With this we covered 3 models. 3 topics are completed. 3 topics note down properly. Next the fourth one is MOSFET model. We'll try to understand. Fourth model is MOSFET model. Right fast here. Problem solve करना भी हम. This is the second slide. If it is completed, give me the message so that I can understand it. I can go to the next slide. Ananya, maybe today the class can go up to 5:30. Okay, 5:30 तक जा सकते हैं. Or 6 approximately. Below that, the class will be completed today. Around 5:30 or 6 because number of questions are more. If it is completed by 5, I am so happy. If not completed, maybe it will go up to 5:30 or 6. Okay. The next slide you can see. Next slide. I completed up to here my work. You can complete MOSFET also. MOSFET also you can complete. This is MOSFET design. In MOSFET, I think nothing is there. Input we are taking open. Output side we are taking a current source. But lambda equal to 0 means no R0. If lambda is not equal to 0, we have R0. In BJT classes, R0 means early voltage by ICQ, output resistance. In case of a MOSFET, it is 1 by lambda times of IDQ. Because lambda and VA both are inversely proportional to each other. We can write here, VA is equal to 1 by lambda. Okay, this is the story. VA is equal to 1 by lambda. So like this, you can have some short notes in your mind so that you can do the problems well. Up to here, we completed 2 topics. 2 topics complete ho gaya with this simple practice. What is the next practice we'll see? That is topic number 5. Topic number 5. Here I am doing 5th topic, that is common emitter bypass. Common emitter bypass amplifier. So if you are not seeing any biasings, all these things, how to recollect the points, seeing the diagram, without any AC model, how to recollect the concept, I'll show you. See the trick. This is RC, this is VCC, this is VI, this is output. If you want to practice the formulas, try to practice with a simple model like this, without considering all the biasings, all these things. Just write a rough diagram like this. You are having input, you have biasing, RC, output. It's a common emitter bypass. Seeing the board itself, you must get the answers. By seeing this arrow here, input impedance, you investigate yourself. What will be there actually? What will be here generally? Means R pi will be there. Otherwise, if RE3 comes, beta RE will be there. Otherwise, hybrid theory will be HI. So anything you can write. R pi will be there. But R pi is nothing but beta RE only. Beta is nothing but HI. So directly answer again. Nothing to remember anything. And what is the output impedance here? What is the output impedance here? Seen from here is, it is RC parallel to R0. It is RC parallel to R0. Because inside we have some R0. When the current source is there, practical current source, we have R0. If anybody say R0, early voltage is infinite, R0 will leave it off because it will be infinite. If anybody consider it, we'll consider it. Only thing is, these two resistance will be parallel to each other because VCC is grounded. So RC will come parallel to R0. That is your output resistance, seeing the diagram itself. This is the second answer. And what is the gain? Seeing this board is, your gain answer is minus GM into your RC parallel to R0. This is the gain. You can see how much easy they are. Completed the formulas. This is about your common emitter bypass practice. So no need of any AC models, straightforward, you can solve the answers. After getting the complete analysis, easy practice. These are my formulas. If you want one more formula, we have a current gain formula also, which we practice it as minus beta into RB by RB plus your R pi. This formula you can practice by current division rule technique. This is a separate formula for you. This is a separate formula. It is minus beta RB by RB plus R pi. So this completes the concept of common emitter bypass amplifiers. The short note should be in your practice. Okay? Hardly 4 points I completed. Input impedance, output impedance. They're all fingertips if you can practice like this in analog electronics. So common emitter bypass is completed. Now let us see common source bypass amplifier is the next point. Common source bypass amplifier. Common source bypass amplifier. So 6th point, we'll go for common source bypass amplifier. So 6th one, common source bypass amplifier. Common source bypass amplifier. If you are going for common source bypass amplifier, how the diagram looks is, it looks like this. If you take a symmetric diagram like this, without taking all biasings, all the stories, if you take a rough diagram like this, you can visualize the answers. Comfortably you can write the answers. The input impedance seen from the MOSFET is always infinite because it's an open circuit. If you want to find out the output impedance from here, we have some R0. If lambda is not equal to 0, we can consider. So these two will be parallel always. So it is RD parallel to R0 will be the Z0. And coming to the gain formula, it becomes minus GM into RD parallel to R0. So this completes the MOSFET common source amplifier problems we can do with this shortcut tricks. So this is called a common source bypass amplifier results. So now you can tell the subject is okay, you are thinking tough, but the subject is very easy. Only thing is we have to think like that subject. One time if you know these tricks, how much time you require to do the problems. Straightforward without any AC model. Today I'll finish all the questions. Only formula tricks I'll apply. Okay? Most of the people will do with the models, but we'll do with the tricks. Today class I'll finish the tricks each and every question. So next one, 6th one is completed. Second, 7th one, continue with that. It's a common emitter unbypass amplifier. Common emitter unbypass amplifier is the next trick. What is common emitter unbypass here is, there will be some RE, we have RC, supply VCC, we have some input here, VIN. This is your output. This is called common emitter unbypass amplifier. Common emitter unbypass amplifier. Common emitter unbypass amplifier. Unbypass means here one extra RE will be there in your contact. Then automatically you should have the concept like this. Here we have, from here to here, we have R pi. From here to here, we have R naught. If you consider everything, these are the concepts. If early voltage is not equal to infinite, R naught will be there. If biasing you have done, R pi will be there, input impedance. So now, if anybody asks me questions, straightforward seeing the board, I'll write the answers. The input impedance, if anybody asks you here, it is not R pi, seeing the board, you can see, it is not R pi. R pi plus some value is coming here. That value we should not write RE, we have to write as 1 plus beta times of RE. It is not RE, 1 plus beta times of RE. Because it's a emitter resistance. We want a base current resistance. Because the current flowing here is IB current. So if you want for base current, the resistance will increase by 1 plus beta times of RE. This is one interesting formula I've seen. And coming to this answer, this side answer, if you see, this side answer, it is what I can say, Z01. This side answer is RC is there here. Top side is RC, but bottom side is not R0. We have some other resistance here. You will take this as Z02. So we have two impedances, top and bottom. Bottom side it is not R0. I said one trick for this. Okay, a classic, a golden trick I told you. Whenever you get like this, you just write here GM extra. So the answer is R0 plus RE parallel to R pi. This emitter degenerated resistance R0 plus this resistance parallel plus GM times of the two resistance should multiply. RE parallel to R pi. So this is about above impedance, below impedance. But who will ask you Z0? Who will ask you Z0? Then answer will be Z01 parallel to Z02. These two parallel combination will be equal to Z0. Okay. Generally, this resistance is very, very high. Below resistance is very, very high, not megaohms, more than megaohms we are getting. So above is only kilo ohms. That's why most of the people will say this answer as RC, the approximate value. They never count the below value, they'll count the above value because below value is very high value. That's why RC will be the answer. If RC is the answer, then what is the gain formula? Is it's a closed loop gain minus GM into RC divided by 1 plus GM into RE. Number of times we have seen this formula in the class today in Actilo techniques. So like this, have a good practice, which makes you to recollect very fast in the exams. This is the closed loop gain. This is your above resistance. This is below resistance. So the final resistance will be like this. So this completes the common emitter unbypass analysis. Today only I think we started common emitter unbypass. These are the results we have to keep as a shortcut practice. Okay? Take one page, separate page roughly, and draw the diagrams. How SAR is visualizing the points. Like that you visualize. These are very easy to recollect the points. Okay? After learning the complete theory, this is very helpful to recollect all these things. Today class nothing here, only shortcut tricks will apply so that what book easily we can complete. Otherwise, if you do like a general manner, every teacher how they do is AC model, all these things they'll apply. It takes a lot of time actually. There are so many questions are there in my book. Each and everything I'll solve only by 2 minutes or 5 minutes max. It will not take much time in my class. You can see the procedures how I'll apply. Procedures how I apply is more important. That makes the speed of operation. So total 7 topics are completed. One more will write, that is common source and bypass amplifier. One more result. Common source and bypass. Common source and bypass. Majumdar, RPi model, why I take most of the time says the BJT model and MOSFET model are similar in RPi method. In RPi, we have taken GM into VPi, correct? In your MOSFET, it is GM into VGS. Both look similar to each other. That's why I take RPi model generally for study purpose. Okay, only for study purpose. Otherwise, you can convert to one theory to other theory and we'll get answers. One time, if you get the answer in RPi, we can make it to H parameters if you want. You can make to RE model whenever you want. You can convert it. That's not a big issue. So Ananya is asking previous slide. What do you miss previous slide? See here. Ananya, आपके लिए previous slide. This is the previous slide. Okay. This is the present slide. This is the present slide. Now we are going for 8th topic, that is common source and bypass. 8th point is common source and bypass. Okay. The next one we are moving to 8th one. 8th one. Common source and bypass. Amplifier. Common source and bypass amplifier. If I go to common source and bypass amplifier, it looks like this. Common source and bypass amplifier is, we'll have here RS, here RT, this will be VDD, this will be your input, you're taking this as output. So just we'll have here open here, we don't have anything here, but here we can get R0 if lambda is not equal to 0. And we can keep some GM here to write output impedances. So first answer, you can write from here, your input impedance, we can write as infinite. If you see from here, your Z01 will be RT. But if you see from the bottom, your Z02, it is same style you can practice. R0 plus RS, these two should be in series, plus GM into these two product. Same style you can practice. R0 plus RS plus GM into R0 into RS. The two resistors should be product with GM. So this is Z02. But if you want Z0, it is a Z01 parallel to Z02. Here also same story, we'll get the net equivalent as RT. Because there's a very high resistance, there's a low resistance compared to that. So RT will be the answer. If you want the gain formula, it is minus GM into RT divided by 1 plus GM into RS. It's a closed loop gain amplifiers. So completed here, this is the story of your 8th point. This is important statements. So this completes the 8 topics, which has covered me 4 topics in my lecture. So last two topics we are making short notes. That is, one is current Actilo techniques. I'll give you a short notes for that. That will help a lot for you to do the problems. That's called how to write the short note observations for active loads. I'll take a fresh slide for that. Ninth point is active load concept. How to recollect the points? We'll write like statements. So please complete it. We'll go for the active load statements. Already 3 done. At least by 3:30 we'll close this formulas. 3:30 to 5:30. 2 hours we'll complete the problems. So after completing these ideas, common source unbypass and common emitter unbypass. So let us have the next issue is active load concept we'll apply. Next one is ninth topic. Ninth one, active load concept. Active load concept. So you can write some important points here to learn this subject in easy manner. Point wise I'm writing. First point, the output resistance Rx seen from collector, or we can say collector you write here, collector C you write, or drain D. The output resistance Rx seen from collector C or drain D is given by Rx is equal to simply or not. Rx is equal to simply or not. In case of BJT, in case of MOSFET, both will have the same answers. You just round up these points. Collector C or drain. Whenever you see, your answers will be active load resistance will be like this. If you go for second point, the output resistance Rx seen from here collector, drain you are telling, here emitter or source. Emitter or source is given by Rx is equal to the output resistance Rx seen from emitter or source is given by R pi parallel to 1 by Gm parallel to R naught. This is BJT class. It's a MOSFET class. R pi will not be there. Only 1 by Gm parallel to R naught. This is the difference between BJT to MOSFET. This is BJT class and this is MOSFET class. In MOSFET only R pi you neglect it. Remaining all the formulas are same. So here we are talking about emitter and source. These are the formulas. Next to type 3 statement. Type 3 statement is the output resistance Rx seen from collector C or drain D is given by drain D for a diode connected transistor. Diode connected BJT conductor, diode connected transistor conductor, because in general we are talking. Diode connected transistor is Rx is equal to R pi parallel to 1 by Gm parallel to R naught. Here Rx is equal to 1 by Gm parallel to R naught. One is for BJT, one is for MOSFET. Concept number 3. Round up these points in the notes, collector and drain. And here diode connected transistor you are talking. Diode connected transistor it is. Last statement, statement number 4. The output resistance Rx seen from emitter, that is E, emitter E or drain, emitter E or source, yes, emitter E or source, yes, for a diode connected transistor, your formula is Rx is equal to R pi parallel to 1 by Gm parallel to R naught. This is one answer. And Rx is 1 by Gm parallel to R naught. This is the second answer. 1 by Gm parallel to R naught. First answer is this one. So this is for BJT class and this is for MOSFET class. So this completes the total story here. These 4 statements we will practice. Active loads are nothing for you. Active loads are very simple to do the problems. This is the statement techniques. Actually step 2, step 3, step 4 have the same results. Only step 1, the results are different. Remaining all the steps have the same results. So this completes my package for you. This is called active load package techniques in analog electronics. So complete this, the last one is frequency formulas. I'll explain you. There are certain interesting formulas. One time we'll recollect. By 3:30 we'll start the practice section of workbook practice. Today I'm expecting electrical workbook. I'll do it. Okay, daily I'm doing EC book. So today we'll do electrical workbook. Electrical you do, ECR you do. The problems are same. Okay, maybe numbers are different. Try yourself questions with the starting mirror that EC book me, and electrical book try yourself questions with that and shift over here. So any one book I'll do it today. So with reference to that book, what are the problems I'm explaining? You just take an EC book. Okay, EC का वर्कबुक रेडी रखो. आपको समझ में आ जाएगा कौन सी क्वेश्चन है. Just you can recollect and you can take that question is completed in your EC book. So I can't take 2 books today. Time-based process. Any one book I'll solve because they are similar problems. Maximum all are similar questions only. No deviation much. So today electrical order में जाऊँगा. Just you can work out the problems. I have to do 2 chapters now. One is MOSFET chapter I have to do. One is BJT chapter. Okay. So first BJT will finish off. Then I'll come to MOSFET problems. Yeah. Today is a tricky workbook I'll do it. because I should not show partiality. So electrical, EC, दोनों को equally and distribute the work. Okay, एक बार आपको EC को teach करते एक बार electrical. Like that I'll complete the task. Because both are equal for me. EC students are equal to me and electrical students are also equal to me. All are equal for me. So can I expect this slide is completed? The last slide. Can I move to the last slide? All the 4 points, please complete it neatly. Give me a chance for last 5 minutes to complete the frequency formulas. Frequency formulas एक बार practice करते हैं. Satyam is asking previous slide. Satyam previous slide में क्या miss हो गया? There's a single slide. There's a single slide. And that only 4 formulas I said: input impedance, output impedance, and voltage gain. ये लिखने के लिए time to ले रहे हो. Okay. So come to the last point. The last point. I think the previous point is 9th point. I think with the 10th point we are going to finish. Last point is 10th one. That is about the story of frequency formulas. The last one is the 10th subheading. Frequency response. Frequency response. In that there are some set of formulas you have to practice. One is current gain versus frequency. In this topic, we have seen some interesting formulas. The first formula I have seen in the class is your F beta means what? It is 1 by 2 pi beta times of Re, that is the input impedance of the transistor, into CD plus CD due to Miller's effect. This is F beta formula. Ft, if you want, it is Gm. This Re will be going 1 by R is Gm, 2 by CD plus CD. This is the second formula. And Ft can be written as Hfe times of F beta, and F alpha is approximately equal to 1 plus Hfe into F beta. Hardly these 4 formulas are important to do these problems. Hardly these 4 formulas to do these questions in frequency techniques. Okay. Next, voltage gain formulas are voltage gain versus frequency. What are the formulas are required here is voltage gain versus frequencies. First formula is FL1 1 by 2 pi CC1 into RS plus RB parallel to R pi. That structure should be in your mind. That amplified structure should be in mind to write these answers. FL2 will be 1 by 2 pi CC2. RC plus RL will be the contact. So you write addition. FL3 is 1 by 2 pi CE times RE parallel to inside is 1 by GM. Fourth formula, FH1 is 1 by 2 pi CIN, that is CD plus CD into 1 plus AV, that is Miller's effect, into RS parallel to RB parallel to R pi. FH2 formula is 1 by 2 pi CD into RC parallel to RL. So these are the basic formulas, which will have a good grip on circuit design part. This is all he can recollect actually. He can recollect all the structures. So this completes your total frequency analysis. So this short notes will practice after studying the complete notes. Have a good revision on this, so that problems doing is very easy now with the short notes. Whatever I taught you, this will help a lot for me to teach the problems now. You'll enjoy the problems very well now. And one more point I want to tell the students. Tomorrow the timing change for schedules has been changed. Tomorrow onwards we'll have parallel network subject will start. 2 subjects they want to keep because by 15th networks they want to complete it. So morning to evening they have given time for me, and evening time networks will take the class. Okay, some students said already networks is completed. For the students, you can listen only analog. After that you can become free. Who has not covered networks, parallel networks will complete हो जाएगा आपको. But after analog you will take more hours networks, sir. Until unless analog is not completed, networks will take 3 hours time. So daily our class will start morning 8 o'clock. Evening 4:30, that is my time they have given. So 8 to 4:30 is analog classes, parallel it is going on. Half an hour break will be there. 5 to 8, 3 hours networks will be there. Every day 3 hours they'll try to complete. And when the analog is completed, he will take a full time for you. Okay, networks will take hardly I think 50 to 60 hours. So it will complete soon by 15th like that. And they said that maximum 2 centers they can open. One is Partner Center and one more is Lucknow Center. Maybe chances are there he's telling. Okay, these 2 centers have a chance to open. Not all centers. Okay, all centers slowly one by one they'll try to open it. First chance is Patna will be there and Lucknow will be there. I'm expecting that 2 centers may be opening. So tomorrow class will start from tomorrow. The class will be starting from 8 to 4:30 my timing. 5 to the class will be up to. Okay, I think we'll start with the 8:30. We'll keep the time not at 8 o'clock. For tomorrow my schedule I'll take from 8:30. I'll take 8:30 to 4:30 my class. This is analog class. Please note down these timings. Will get confused otherwise. Tomorrow timing is 8:30 to 4:30. Kolkata Center, I didn't get any information, my friend. Shalini, maybe they're expecting, they also don't know, they're expecting. So 8:30 to 4:30 tomorrow analog class. 5 to 8, the class on networks. So please note down these timings, otherwise you'll forget for tomorrow class. Don't forget it, the timings you write. Sometimes 8:30 was sometimes 8 o'clock only I'll start. Tomorrow I'll start at 8:30. Yes, Swati, I think we'll opt for online. They'll get online videos, will come, don't worry about that. Okay? Because all the students will not expect to come to the classes. So who is not coming, for that live classes will be going on for that. Okay? Online classes के लिए will opt, they'll have online classes. No worries. Okay? You can sit at home and you can study. So please note down tomorrow class. It is not 8 o'clock. Tomorrow 8:30 to 4:30 I'll complete my course. And 5 to 8 separate networks will start tomorrow. In West Bengal situation has been normal. If it is normal, Rahman, definitely the classes will be started soon. Don't worry about that. Okay? Slowly they are starting one by one. Okay? East center open kar rahe. Maybe your center also will get a chance. This month only will get a chance. Indra Kumar, this 12 hours class is only for some days, okay? And after completion, you'll have normally again 8 hours class only. Don't wait, karna, because schedule has to complete. Okay? The planning has to complete. That is the reason. Otherwise, nothing is there. Sometimes you have to bear the timing. Arka, who has completed networks, has been completed to some batch. That batch students, you practice Nlog. Okay, Nlog class only ke baad, you can leave it. No need of studying network again. Nlog practice karke, come for the next Nlog class. Nlog only tak Nlog complete kar dijiye. You will be free when the network is going on, so that you can revise the remaining subjects. Who has not listened, they try to listen it. So tomorrow timing is 8:30 to 4:30. Okay, let us start our class. Let us start our story now. Let us start our story. Electrical book highlight kar raha hu main. So we have workbook practice questions. I'll write first. Workbook practice based on common emitter and common source amplifiers. Only based on these two topics. What are the questions I can do maximum in electrical book? I'll show you. The same questions you try to pick in your EC book when I'm doing the problems. Okay, in this board I'm writing only for electrical. So chapter 5 it is electrical book. For EC, what is the chapter you try to see? Chapter 5. It is for electrical book I'm talking. Chapter 5, which is called small signal analysis of BJT. We're talking here BJT. Small signal analysis of BJT amplifier. We have question 1 here, question 2, question 3, question 4. It is in order, these questions. Nice to do the problems. Question 5, question 6, question 7. You can see a lot of questions are there. Question 8, question 9, question 10, question 11, question 12, question 13. Maybe 14th question became common collector. Question 15, active load problem. Question 16, active load problem. Question 17, question 18. Again, common base question came. Question 20, you can go. Question 21, question 23, and T2, T3, T4, T5, T6. So these questions are from EC book, chapter 5. Let us finish these questions, then I'll come to MOSFET questions. Okay? First we'll complete this one, then I'll write the numbers for MOSFET chapter, then we'll complete that questions. I think you can see this total workbook has been covered most of the questions in this, what I can say, common source and common emitter amplifiers. Summary, your chart is visible, don't worry. Shall we? They'll announce it, no worries. Okay? Until unless network class is not completed, they'll not keep any other subject for you. So cool, be cool. Otherwise, we have our group. In that group, they'll try to message our students who is listening so that they'll get updated your information. So after Nlog class also, in that what I can say Nlog WhatsApp group is there. In that you can update any information is there. Some other student will take the help of that. No problem. You can update the informations and you can discuss the doubts also. No problem. The group is meant for making your doubt to solve yourself. Okay? So like that, you just share your doubts. Your friends will solve it in that group. It will be continuing like that. That group up to your GATE exam and ESA exam. It will be in contact. So that okay, WhatsApp will not be removed after my Nlog class. It will be there like that. So you'll be in contact with me always. Okay? Indra, I don't know here who will teach networks because there 2 or 3 teachers will be there. Whom they are keeping, I don't know. So don't ask me the questions. So now one by one, we'll start the electrical book. Question 1, system. Let us see how the questions can be taken. The first question, if you understand clearly, question number 1. He has given here an amplifier circuit for you like this. 900 kilo ohms. There is a capacitor here. And we have 3 kilo ohms. And we have some biasing resistors. 100K. This is my input. This is 20K. This is 12 volts. And you have the output. This is the circuit. He has given some data for you saying that your input of T is equal to A cos 20T plus B sine 10 power 60. This is the concept he has given. And beta he has given as 150 and HIE he has given as 3 kilo ohms. He is asking you what is V naught of T. This is the first question for you. Generally any amplifier you take, this is what type of amplifier you can take. It's a common emitter bypass or unbypass. Tell me the response quickly. It's a common emitter bypass or unbypass. Come on. Satyaprakash, in EC what is the question number? You see in your workbook. Workbook may diagram take somewhere, it will be there in workbook. You just take the question, it is completed like that. Okay, don't ask me the question number. So it's a bypass or unbypass? It's a bypass. Great. It's a bypass. It's a bypass amplifier it is. So maybe bypass or unbypass, the formula is V naught of T will be equal to your voltage gain times of your input of T. And EV we have to take for bypass amplifier. It's a bypass. EV we have to take for bypass. Okay? And he has given here, have you observed, HIE is given in the problem. That means he is intentionally asking you to do this problem in H parameters. Like that you have to understand. Whenever they give HIE, go for H parameters. What is the formula for bypass formula is? Actually it is a current gain into load resistance divided by your input impedance. This is the formula we have. Get it? Okay? This is the formula I got. 2-port network formula. Current gain means here minus HFE. Load is load. Input impedance is HI. So this is called approximate model and written. Why is approximate model means? In this question he has not given HRE and HOE. If they don't give, I'll go for approximate formula. So just I apply the formula. So what is HFE here is? What is HFE means? Beta, it is 150 into load. Load is 3K, input impedance is 3K. So answer is minus 150. Nicely, I got the gain. The gain is completed. Whenever you got the gain, have you observed why should I give like this? Is there any logic for this? You can see. One is 20, one is 10 power 6. What is the meaning of this is? This is considered to be a low frequency going. This is going to be a high frequency. One is a low frequency, one is a high frequency. I said in my class one technique for you. Coupling capacitor will get open circuit for low frequency. Coupling capacitor will get short circuit for high frequency. That means this capacitor, whatever you are seeing here, last capacitor, this will not allow the input to go, but it will allow the input to go for 10 power 6. That means it is just this capacitor is just blocking low frequency components. It will just block the low frequency. Low frequency component will be blocked. That is the meaning of giving this signal. High frequencies, your capacitor will be short. Low frequencies, the capacitor will be open circuit. So I think your answer should be only B sine 10 power 60. So this will become your V naught of t. This will become your V naught of t. This answer is minus 150. So can you see that the output is coming like this? So that is the secret of this question. So whenever they give for RC coupled amplifiers, low frequency, high frequency, low frequency you have to stop it. Only high frequency you have to take as an input. So that is the meaning of this concept. Yeah. Lucknow, I think they said 15th October. That's it. वो छोड़ दीजिए. अब ये problem करो. Can you give easy students? Can you tell me what is this number so that I'll write there only? Easy students, see your workbook. Which number it is? Tell me there. I'll write so that it's easy for the students who is listening this video. Immediately message me which number it is. Question number in EC. This question from EC book. Which number you identified? So option D you can take this answer. Option D is the correct answer. The first question I have done simply like this. It's a question number 7 in EC book. In EC book it is question number 7. This question is concerned to EC book question number 7. Thank you. Let us start the second problem. Question number 2 I am doing. VS capacitor. We have 3.3K and we have 4K and we have biasing 60K and 30K. The battery here is 12 volts and you are taking the output V naught with the capacitor here and HFE is 50 given. So this is the question here. Is asking you voltage gain. AV is equal to V naught by Vs. The first very important point is there any resistance here? Means your RS value here, your RS value is 0. When RS is 0, the voltage gain of your amplifier will be same as the voltage gain V naught by Vi of your transistor. So this is Vi if you take, Vi and Vs both are same. So the transistor gain and your amplifier gain will be same, first point. And the circuit name is called common emitter bypass. It's an unbypass native bypass. So transistor gain for bypass, I know the formula is minus Gm times of load. This is the formula I know. Voltage gain is equal to minus Gm times of RC. So this formula, how to apply in this board, we'll see. HFE has given 50 here in the problem, but HFE can also be called as beta only. HFE can also be called beta only. So this formula, if you write the gain formula, Gm is nothing but minus ICQ divided by Vt, which is reverse to dynamic resistance, into RC. I think this will solve the problem. So I think I've not taken much time. The problem is completed. Just I understood the concepts. Circuit gain and your transistor gain is same. It's a common emitter bypass. The gain formula and Gm formula I know ICQ by Vt. Problem is completed. But here the job is ICQ will come from biasing circuit actually. So first you have to solve the biasing circuit. There is an extra job for you. Biasing circuit. That means you have to go for DC analysis. You have to draw for DC analysis. 3.3K. This is 4K. This is 60K. And this is 30K. This is 12 volts. So first draw the DC circuit. And if you can solve this current, which is nothing but IEQ. If you can solve this current, IEQ and ICQ will be same. Because beta is given 150 I think. Beta is given high beta, so IEQ and ICQ will be same. Let us find out this answer first. If you want to find, we have this basics called base voltage. And this voltage will be 0.7. This voltage is emitter voltage. In the initial classes we done these problems, correct? Base voltage find out first. It is 12 into 30K by 90K. So base voltage is coming 4 volts. Base voltage is 4 volts. Then I think emitter voltage will be 4 minus 0.7. It is 3.3. So what is ICQ? Which is equal to IEQ. Which is equal to 3.3 by 3.3K. Which is equal to 1 milliampere. So operating current, I am solving with the DC part like this. One time operating current is completed, you can solve the gain formula. Minus 1 milliampere by, have you seen in the question? In the question Vt is not given in the problem. If Vt is not given, default 25 millivolts we have to take. Don't take 26. 25 is default. 25 millivolts into RC is 4 kilo ohms. So this is the way how to solve this problem. And he said that modulus. Okay. First answer will come negative answer. Maybe minus 160 will come. If you want modulus, then answer will be 160 will be the answer. So 160 will be the answer for it. So you can see the style, this amplifier problem, having Gm is depending on operating current. So first you have to do the DC problem submodule, you will get the answer, then you will get the gain. So gains always come from Gm. Gm always come from the biasing circuit. So first to biasing you must be confident. So this question I think, EC students, I think this question is there somewhere in your EC book. Can you identify the number for EC book? Meanwhile, you can identify the number. In EC book, what is that number? Question number 5 for EC. Okay. EC book. it is question number 5. This question we have completed in EC. In electrical book, it is second question. In EC book, it is question number 5. So let us move to the next question. So I hope you understood it. Concept is clear. Bypass formula applied. In that GM, I want to know. GM is nothing but ICQ by VT. ICQ will come from your voltage divided biasing circuit, which we done in our previous classes. Shabani Das, here R is equal to 0. किधर लिखता हूँ मैं? अब R is equal to 0. R is equal to 0 means source resistance is not given in the problem. If source resistance is not given, your amplifier gain and transistor gain will be same. I am telling you. This formula is only for transistor gain. A transistor gain, amplifier gain, same over here. That's why amplifier gain I have written same answer. But sometimes in the exams they'll give R is extra. Then I said that you'll get some division there. R is by R is plus Z, some formula will come. In two-port network theory I thought in hybrid techniques. So hybrid parameters एक बार पढ़ो समझ में आता है मैं क्या बोल रहा हूँ. ऐसे भूल you're just forgetting it here. A point पता है ना? When RS is not there, it will become an ideal model. Directly circuit gain and your transistor gain will be same. They're all the transistor gains actual. We are making equal to amplifier gain. Okay? शबनी दास आपके लिए बता रहा हूँ. Gain is how you are asking. ये पूरा story खत्म कर दिया मैं theory में. Question number 3 I'm doing. Question number 3. If I say clearly question number 3, this is your VI. Next we have capacitor. Next we have 10 kilo ohms. Next transistor. This is 1 kilo ohm. This is the capacitor we have. This is 10 kilo ohms. This is your VCC, your output. Can you tell me what he has given here? It's only HFE as well. HFE, he said 100. HFE is 100. Now he's asking the question, can you calculate the midband voltage gain? Don't confuse with this word, midband. Midband because amplifiers will work only in midband range. Midband voltage gain. Midband voltage gain is also called as your AV, circuit gain. Okay, your AV gain. So midband voltage gain is nothing but AV, means circuit gain you want, output by input. Output by input, you have to calculate. Then can you write some AC model for this, seeing the board? This is VI. Because I want some clarity here, you get some resistance, that's why I'm writing AC model. This is 10K, capacity short. And this capacitor is also short, AC model. So we have only R pi here. Here there will be some R pi. The next we have is a current source, GM into V pi. After that we have some resistance here, that is 10K, this is output. So just seeing this model, first I presented the what I can say AC model for it. We have 10K here, this is R pi, this is current source, this is load 10K. This is called AC model for it. If I want the gain for this formula, can you find out the gain for this? This is V pi here, this V pi. This current is going in this manner. So what is the output here is? Output is equal to minus GM into V pi into 10K. Okay, I have written minus GM into V pi into 10K. Then V pi is nothing but VI into R pi by R pi plus 10K. So I have written like this. Okay, so one thing here I have doubt is R pi is given in the problem means R pi is not given. R pi not given, HI is also not given, but beta RE we can solve from biasing, but biasing also not given, VCC is unknown. That means you want to tell that your R pi can be neglected, because VCC is not given. If VCC is not given, then how you can find R pi? R pi is nothing but beta RE. So beta RE will come only when there is a supply, but you are not given. So indirectly R pi is neglected in the problem. Then if R pi is neglected here, can I say this V pi will become 0 now because R pi is 0 I have taken. So V pi you have to take 0 because R pi is neglected in the problem. If R pi is not considered, this will become a short now in the problem. If this becomes a short circuit here, this total becomes short because I don't consider it R pi. So we have the model like this now. So can I say that VI is across 10K only? VI is across 10K. So these formulas we should not use because V pi is 0 here, R pi is 0 here. So how we will find out this answer is, we'll go for another trick now. Okay, because V pi became 0 here. So why can't you change the concept to current technique now? This will take it as HFE times IB will take, because V pi we are not getting the action. So HFE IB, here we have some current IB like this. So find out the output. So this formula is not useful now for us. So V0 is equal to minus HFE IB into 10K. Like this you can write. In terms of voltage we cannot find, in terms of current we can find it. So IB is nothing but VI by 10K. VI by 10K. This is 10K. 10K is cancelled. So output by input in magnitude, it is HFE, which is nothing but 100. So answer is 100 is the correct answer. Have you seen the style? How the examiner is confusing the people? Here, when I write R pi model, okay, we are not getting the answer. 0 is coming. But when I convert into current technique, I am getting the answer. So this logic we can use with the H parameters directly. Because in the problem he has given HFE, so go for H parameters, saying that here HI is neglected. HI neglected. Because if they don't give HI, at least we must give biasing circuit for you. But in this problem, no biasing is given. Means he is disconnecting that HI model in the concept. Disconnecting means in essence neglect karo. Examiner indirectly telling the story that you have to neglect it. Yeah. If RS is given, if any resistance series, you write a model like this. Otherwise, it is not good for you. So this story you can leave it off. You can solve like this, simple. You just write this model and just write this answer. Convert into H parameter model, neglecting HIE, HFE, IP, will get the answer. So what is this question number here? In EC book, what is the question number? Question 3. What is the EC number? Just give me the idea, I'll write in the board. It's a EC question. EC question, how much? Identify that question. Yes, Swati, if a biasing is given, then only we can solve it, HI. If biasing is not given, I cannot solve it. That's why I neglected number 6 here. This problem is concerned to AC number 6 question. So coming to the fourth question. Fourth question is a very simple question. He has given load as 10 kilo ohms. Load is 10 kilo ohms. HFE is 100. And HIE is 2 kilo ohms. Saying that HRE, HOE is 0. What is the voltage amplification he's asking? That is AV he's asking. So if you neglect this one, I think our formula is A into RL by ZI. This is the two-port network gain. So current gain here is input impedance. We can take HIE load. Just solve this answer. It's a straightforward question. It is minus 100 into load is 10k by 2k. It's coming to be minus 500. So in magnitude, if you want this answer, you can take it as 500 will be the answer. So question number 4, 500 you can take the answer. So I think voice is not coming. Voice is coming here, I think. Voice. No, your voice is coming in my laptop. It is coming voice. So I voice check karo. Students are writing voice is not coming. Mic is not off here. Voice is coming clearly. Just one time check your one more time. Abhi aa rahe Swati? Voice is coming now. Okay. Voice is coming now. The RL given HFE, HIE. This is not given here. HRE, HOE. Just an approximate model I have used. When approximate model if I use current gain form HFE, we'll write get input impedance को HIE लिखते हैं. Problem solved. Okay. Two-port network formula applied. So you can check your EC book. What is this question? EC book में question क्या है? किधर से? Which number it is? You can check it. Next question number 5 I'm doing. Question number 5. He has given some RS. We have VS. Next we have some coupling capacitor. We have transistor, ground. We have some RC. The coupling capacitor with the load, RL. This is your output. This is your VCC. There is some resistor here, RB. So like this you are seeing a model. He has given a lot of data. I don't want to write the total data. The first question is the resistance seen from the source. He has given some RS here, seen from the source. Can write an AC model for this. It will be easy to finish the problem. AC model you write whenever RS is given. You will get a clarity here. VS, next to RS. VS, RS will be there. Next we will have short here, capacitor. RP will fall to ground because supply is ground. RP will fall here because supply, it will be grounded. So I pended the resistor to ground. The next will be some RPi will be there. BJT transistor RPi. The next we will have some current source here. Current source, that is GM into V pi. Parallelly two resistors are there, RC and parallel to RL. This is your output. This is AC model I have written. He is asking you what is the input impedance seen from here. Or you cannot calculate directly seeing the board. Your input impedance will be how much? Both take the answer available. The answer is RS plus RP parallel to RPi. This is your input impedance. RS plus RP parallel to RPi. In the problem he has given RS has 1 kilo ohm. RP has how much RP? 93k has given. RPi also given 259. So if you see this formula, one resistor is very high resistance has given, one resistor is very low resistance. So don't waste the time in gate exams. You just write 1k plus low resistance. So that approximate answer you will get. So I got 1259 ohms as an approximate answer. If you see the option 1258 ohms he has given, so 1 ohm difference. So why can't you do like this? Unnecessarily wasting the time. Whenever high resistor, low resistor is given, just write low resistance, solve it. So 1259, the answer you can take 1258. So one more question he has asked. What is that? Bit number 2 is talking about second bit. Second problem is asking about frequency concept. That is your FL across C2 capacitor. This formula is a very silly formula. Easily you can do it. Correct? Across C2 means it is 1 by 2 pi C2 into RC plus RL. The addition of these two resistors is the answer I said. So with this you can solve it. 2 into 3.14 into C2 capacitor is 4.7 into 10 power minus 6 into RC value is given as 250 ohms plus 1 kilo ohm. This must be the FL at C2 capacitor. Already Raghavendra Pratap has given the answer 27.1 H. Perfect. FL at C2 we can solve it. These are 2 marks question given in gate exams. Okay? We will have the basic standard knowledge. Doing problems are nothing here. One time you practice the complete workbook, whatever I am doing, you will get a confidence how to do the questions. Okay? You will get a hobby to do the practice of amplified questions. Up to now there is no pain for me. Each question is simple. 5 questions complete हो गया. Let us target the 6th, 7th questions. All simple questions are there now. 6th question एक बार read करो. Electrical workbook. 6th question. Question number 6. Theory question is asking. Question number 6. Question number 6. If you see the frequency plot, we got like this. RC coupled frequency. I said that there will be 2 frequencies. One is FL and one is FH. This is the concept. He's asking you at lower frequencies which capacitors will disturb, at higher frequencies which capacitors will disturb. I think at lower frequencies I said CC and CE are disturbing the concept. And here CD and CD are disturbing the concept. These 2 things you should have the knowledge. These are called your coupling capacitor and bypass capacitor are disturbing here. At low frequency, the gain is reducing due to these capacitors. And if you go here, it is due to junction capacitors we can write. Junction capacitors. Internal capacitors come both junction capacitors are creating problem at high frequencies. This is for low frequency problem and this is for high frequency problem. So now you can answer your question clearly. What is the meaning of C1 is infinite means he has taken a very high capacitance. Okay, if you take a very high capacitance, what happens is it will get shorted from F equal to 0 onwards. Okay, that is the meaning. Infinite capacitor if you take, it will get shorted at F equal to F is greater than 0 onwards, it will get shorted. If you don't take infinite capacitors, they will get shorted after FL. Otherwise, they will get short from F equal to 0 onwards. That is the meaning of C1 equal to infinite. Okay. Hey Samresh, I have not taken 259K here. Previous problem है 259K कौन लिया? Where is that problem? 259. This is 1K here. This is 259 ohms. That is not K, ohms. There's ohms here. 259 ohms. And final answer we got 1259. 1259 ohms we got. It's not kilo ohms. Ohms it is. So this is the answer. What should be the option here? Option D will be the correct answer for this. Option D. Now suppose somebody said in question number 7, what he's telling is, if coupling capacitor is shorted, if coupling capacitor is shorted in your RC coupled amplifier, then what will be the response he's asking? If coupling capacitor is shorted, next we have is capacitor, coupling capacitor is shorted, next we have is some RP, next we have is transistor, like this we are seeing. When there is no capacitor here, there is no capacitor here, okay, I think your signal happily going to the transistor. Whatever you are giving your signal, it is going to the transistor. That means what? Low frequency wise, we don't have any problem. Only high frequency wise, the transistor will create problem. So transistor create problem at high frequency. Problem at high frequency. So I think for low frequency, it is working good. Low frequency, signal is passing. High frequency it is not passing. Therefore, your response will look like a low pass response. It is working like a low pass. High frequencies we are getting disturbance. Low frequencies we are getting problem here. So this is the option. So you can take this option as option B. You can take the answer. So whenever coupling capacitors are being shorted, okay, so I think it will behave like a low pass response. Okay, it will behave like a low pass response. So that is the story of when capacitor is shorted. It will behave as a low pass response. High frequencies it will create problem. Low frequencies it will not create any problem. 8th question I am expecting every student will tell the answer for 8th question. It's a theory question again. 8th one. Just try to solve yourself. 8th one. 8th one. Please try to solve yourself. 8th question. 8th question. Everybody can do it. If you see 8th question here, it's telling that common emitter with emitter resistance in a common emitter is not bypass. It will be. That means he's talking about common emitter and bypass. You know that in common emitter and bypass, the gain formula which we got is minus Gm into RC by 1 plus Gm into RE. This is the formula we got. That means the gain is decreasing here. Gain is decreasing. And input resistance, if you see from the base we have seen, it is increasing by R pi plus 1 plus beta times of RE. Can you see that input impedance is increasing? So this is the story of the common emitter and bypass. It's talking about common emitter and bypass. What happens to your input impedance? What happens to your voltage gain? A very simple question it is. Very standard question. Reduces the voltage gain and increase the input impedance. You can take this as option B. Option B as an answer. Question number 9, you can see. Ninth question is also a simple question. What is FT is asking? FT now only we studied. It's a unity gain bandwidth frequency. What is the answer for that? FT answer. Ninth question, please tell the answer. Who is this? Raghavendra. Option A, Galat Nair. Option B is correct. 8th question, option B is correct. Input impedance will increase and voltage gain will decrease. That is correct. And 9th question is asking you, gain bandwidth product FT is what you mean by that definition. It is the frequency at which common emitter short circuit current gain reduces to unity is called the concept. So beta of the transistor should falls to unity. Anupam Das and Tripti Roy, Galat bol rahe are options. Correctly read karo statement ko. Correctly read simple statement. Morning class I think just before 2 hours I have been completed that FT story. You are telling wrong answers. So concentrate karo. What is FT I said in the class? Beta of the transistor. That is beta of the transistor. Beta of the transistor falls to unity I said. Falls to unity. Beta of the transistor will fall to unity I said. So option C you can take answer, not B or D. Very simple question. यार इनको भी आप mistake कर रहे हैं. Again somebody is telling 920. Power gain of the transistor falls to unity. Who said power gain here? I have not said power gain. I said HFE. HFE means beta. Current gain falls to unity. You are telling power gain. It's not power gain. Current gain falls to unity. Next question number 10th one is talking about FT formula. FT formula is Gm by 2 pi CD plus CD. So this is the formula we have. FT formulas. Gm by 2 pi CD plus CD. These are formula based questions. Okay. Gm is nothing but simply IC by VT. So based on this you can solve this problem. FT given, ICQ is given, so Gm will come. It's talking about C pi and C nu. C pi means already I said CD ko C pi concept and CD ko hum C nu. There is another notation C. So C nu is asking the problem. C pi is given, C nu is asking. So let us find out C nu is equal to CD. It comes around 15 picofarads will come. If we solve this problem, it will come 15 picofarads. Yes, Ditya Das gain Fox 2 unity is correct. Great. Current gain, not gain, current gain. So just take copy the formulas and write the results. Afterwards you can calculate. Next question number 11, you can see. This is question number 11. Is asking what is FT and beta. First FT ko calculate karo, same formula. GM by 2 pi CD plus CD. He has given the complete data. GM he has given, C nu given, C pi given, beta given. I think all the things he has given. Just you have to solve this one. I think I'll get around the answer here. 1.47 into 10 power 10. H will come. When you solve FT, this is the answer. If you want F beta, you can say FT by beta you can write. Because beta into F beta will be FT. So F beta chahiye to FT by beta you have to write. So this answer will be coming around 1.64 into 10 power 8 H. So these are the options you can take. So I think this option is A. 10th question, option is A. 11th question, option is B is coming. 11th question, option is B. Okay. Next, coming to the 12th question now. Question number 12. 12 and 13 are simple questions, you can finish off. 12th and 13th questions. Try to solve 12th and 13th by yourself. 12th and 13th. He's asking FT and F alpha questions with respect to F beta. Simple questions there. So let us see. Question number 12. Question number 12. F beta is given as 1 megahertz and beta is given as 200. Is asking FT. It is beta into F beta is the answer. Beta is 200 into 1 megahertz. 1 megahertz. It will be 200 megahertz. This is your FT. F alpha if you want, the formula is I said 1 plus beta times F beta you have to solve. It will become 1 plus 200 into 1 megahertz. So it will become 201 megahertz. It's slightly greater than FT. Option A will be the good answer for this. These are all things we have done in my short notes, so I'm writing fastly the answers. Question number 10 में क्वेश्चन नंबर 10 में क्या किया यार? क्वेश्चन नंबर 10 में क्या किया? फॉर्मूला अप्लाई किया. दिस इज अननोन. आई एम सॉल्विंग दिस आंसर. समरेश, इनमें कोई नहीं किया मैं. फॉर्मूला हमको मालूम है. फॉर्मूला से CT is nothing but C nu बोल रहे हो. इंडिकेशन है CT is C nu. C nu I am solving given other parameters he has given. But he has given IC. So first GM calculate करो. IC by VT. Then solve it I said. Nothing more than that I said. So coming to the 13th question. Question number 13. Question number 13. He has given operating current is 1 milliampere. Operating current is 1 milliampere. Beta is 100. Beta is 100. VT is 25 millivolts. He's asking you find out GM and R pi how much. These two answers he's asking. Whenever ICQ is given, the problem is very simple. ICQ by VT is GM. This is known fact for us in the problems. GM is nothing but 1 by RE. It is reverse ICQ by VT. What is ICQ here is 1 milliampere by 25 millivolts. It is coming to be 40 millisiemens. 40 millisiemens is GM. Otherwise 40 milliampere per volt you can write. And R pi is nothing but beta RE. Otherwise you write beta by GM. In short notes I have given this practice for. R pi can be written as beta RE, otherwise beta by GM. So beta given in the problem is 100. Then GM will be how much? GM is given 40 millisiemens. GM is given 40 millisiemens. So the answer will come around 2.5 kilo ohms. So this is the simple problem. GM problems and R pi questions. So which is matching here is option D is matching here. Option D. Up to 13 questions we have completed. So please complete up here. 13 questions are completed. Next target is 15, 16, 17. Actual load questions. You try to solve it first. So 15th, 16th, 17th, 3 actual load problems. You can do it nicely, these 3 problems. So we'll go for actual load questions. You can see the 15th question style. 15th question. He has given a transistor Q1. Above this we have 1K. This is 5 volts. This is your signal source Vs. And next we have a PNP transistor with a minus 5 volts battery. There is a capacitor and there is a resistor. This is RP2. This is ground. This is Q2. This is output. So what I said in the class, whenever you see any actual load problems, what you have to do first point? You have to do AC analysis first point. Don't forget it. AC analysis you have to do. AC analysis means this will become ground. That also becomes ground naturally. If this becomes ground, AC analysis, this point will become ground. This capacitor is getting shorted in AC analysis. This AC analysis we are doing. Capacitor should be short, DC should be ground. I think this point is ground. If you correctly observe, this is also ground, this is also ground. If these two are getting grounded, how this model looks for you? This is ground, your V0, this is Vs, this PNP transistor. Can I write like this? This is what I am saying. This is all grounded, so no current will flow here. So the current flowing here is 0 here. No current is there means it's a short. So I think I am seeing an actual load here. So this is considered to be your actual load. And it's a diode connected actual load where emitter, PNP means emitter is there. You have to find Rx. We say emitter is the resistance we are finding. Rx formula we know it is R pi parallel to 1 by Gm parallel to R naught. This is the actual answer. Whether we have to take this complete answer or not. In the problem if you see he has not mentioned R naught. So R naught को neglect कर दीजिए. He has not mentioned R pi. R pi को neglect कर दीजिए. Then Rx you write simply 1 by Gm. What Gm it is? Gm2. Second transistor का Gm. So whatever you practice, same style. 1 by Gm2 will be the answer. R naught not given, छोड़ दीजिए. R pi not given, छोड़ दीजिए. 1 by Gm2. Then what is this amplifier is? It's a common emitter unbypass amplifier. It's a common emitter unbypass. We have RE here. This amplifier, this is RE. So the gain formula is asking. It is minus Gm1 first transistor into load 1K divided by 1 plus Gm1 into Rx. It is 1 by Gm2. This is not more than your Rx point. So just say substitute Rx here. Okay. And he said that Q1, Q2 are biased at the same operating current. If same operating current if you bias, then what happens? Your Gm1 is equal to Gm2 is equal to Gm. So both the Gms will be same when the operating currents are same because Gm is proportional to operating current. So that's why in the statement clearly you have to understand both the transistors are biased with the same operating current means Gms will be same. So if Gms are same, you can write it as minus Gm into 1K by 1 plus 1 plus 1. These are same Gms, so 1 plus 1. So answer is simply minus Gm into 1K by 2 is the answer. So Gm you have to find out in the problem. Gm is nothing but ICQ by VT. IC by VT. IC how much he has given is 2.6 milliamperes by VT he has given as 26 millivolts. Answer is 1 by 10. It is 1 by 10 ampere per volt. 1 by 10 ampere per volt, yes, get it. Okay? Gm is 1 by 10 ampere per volt. So answer if you write, it is 1 by 10 into 1000 divided by 2. It is 1000 by 20, maybe minus 50. So the gain is coming to be minus 50 is coming. And he said that magnitude. So answer is 50. So whatever we studied, same thing I have done there. Okay? Active load concept. So Anupam Das, it should become a hobby for you GM. Oh, क्यों इतने परेशान हो रहे हो आप? GM इतने बार किया मैं. Again you are asking me. The formula is ICQ by VT or not. क्यों इतने लॉजिक नहीं क्यों नहीं आता यार आपको? इनका ऑपरेटिंग करंट सेम होते हैं. ICQ will be same or not for both the transistors. ऐसे लॉजिक यूज करो यार. GM is so many times I taught in the class. You should not miss the concentration there. So he said that both the transistor operating currents are same means compulsory the GMs of both transistors will be same. If the operating currents are different, GM will be different. Okay? So that is the reason story came like this. These are 2 marks questions. 16th question I think you can do it at least without my help. At least do it 16th and 17th. Try to solve by yourself. I have done a good work for you. Whatever the knowledge I have given, it's one of the best knowledge to complete these questions. It does not require much patience to do these questions. Question 16 and question 17. Try to target. Question 16 and 17. So I'm expecting now 16th and 17th question. एक बार try करो यार. 16th and 17th questions. Question number 16. He has given here a transistor. This is your input. This ground. Here we have the V0. Okay. This is the transistor circuit. He said that 2 BJTs are biased in active region and have the identical parameters. I think Q1 and Q2 are having identical parameters. Understand the statements. Identical parameters. What is the meaning of identical parameters is, it is biased in the same place, same environment. So GM1, GM2, you can take GM. Beta 1, Beta 2, you can take beta. These are all same. Okay, all are same. Identical means that is the mean. Now according to this problem, can you see that there is a Rx here? There is a Rx, which you are taking from collector point. You are seeing from collector, it's a PNP transistor. When you see from collector, the answer is here 1 by GM2. This is Q1 you take, this is Q2. This is 1 by GM2 I have taken. Okay, parallel to R pi, ऊपर नहीं दिया, only 1 by GM2 I have written. So the gain formula will be, it's a bypass problem. It's a common emitter bypass. Because only this is RC load, it is minus Gm1 into Rx. This is answer. So answer is minus Gm1 into 1 by Gm2. Can you see the answer here? Both the Gms are biased at the same operating point, he said, and all are identical. So if they are identical, they should be cancelled. The answer should be minus 1. That's why these circuits we call popularly as inverters we call, okay? Phase shifters we call in digital electronics. If you want to make a phase shifters in digital designs, this is the best phase shifters. Where Q1, Q2 you make it identical, and just to bias with the same operating current, then automatically they work like a phase shifters in electronics. It's a minus 1 is the answer. 17th question also you complete. Question number 17. You have a transistor, VIN. This is R1. We have a short, a supply, VCC. This is your output. This is T1, this is T2. This is the circuit we are seeing. Question number 17. So this here also you can see active load. There is an active load here, which is emitter is there here. Can you tell me what is Rx here at emitter? Rx. It is R pi parallel to 1 by Gm. Is there any R not given in the problem? Is R not is not given. Okay, operation activity, early effect is neglecting early effect, he said, so we can neglect this or not. And the problem he said, neglect the early effect. So I think R pi parallel to 1 by gm I kept. So I can write this total answer is my load. This total is my load. So what is the gain formula here is minus gm1, first transistor gm1 into, this is the load, R1 plus Rx. R1 plus Rx is the answer. It is minus gm1 into R1 plus R pi parallel to 1 by gm. So you can say this option will be seen in your book. Boss option D कैसे आया यार आपको? ये आंसर आ रहा है मेरे को. R1 plus, you can write this as two parameters. This is the second transistor parameters. R by 2 parallel to 1 by gm2 plus R1 will be the answer. Yeah, 17th question. Option D गलत यार boss. Akash, option C. Yeah, option C is correct answer. For 17th question, option C is better answer for it. Okay? So it takes only hardly 10 seconds to answer these questions. Just whatever the tricks I told you in my notes, apply the tricks, first find out Rx and get the answer. It's a bypass amplifier. So the gain is minus gm into RC. That RC became here R1 plus Rx. That will complete the problem for it. Great. 17 questions complete. Okay. Now 18th question I'm saying. Let's see. Some confusion will come for the student. 18th one. I'll avoid that confusion for you. 18th question. 18th question. Question number 18. Sometimes they'll write irregularly the models. Then how to write properly I'll tell you. See. Vs. Next we have 1K. This is capacitor. Here we have resistor 10K. This is 1.5. Next we have PNP transistor as well. This is the 100 ohms. You're taking the output at collector. And there's a current here 10 milliamps. There's 5 volts. Capacitor to ground. This is a circuit you're seeing. Carefully observe it. The circuit, are you feeling common emitter or common collector? How you can recognize it? Irregularly they'll design it in and log. But how to catch it is very important. It's a common emitter or common collector. Yeah, Parthasaldi, it may be PNP or NPN. Whatever maybe you take. Emitter side Rx is different. Collector side Rx is different. The two tricks if you know, any problem you can solve. Okay, it's not the bothersome of PNP or NPN. It's the bothersome of where you are taking the Rx. Collector mein le rahe or emitter mein. That is important. Carefully see here. This base is input. Base is input here. And collector is output. So this is the way how to recognize the problems. Base is input, collector is output, then what happens? Then automatically emitter is common. Emitter is common. So I think this transistor name is common emitter amplifier. And we have some CE capacitor here. So it is a bypass. So like this you have to understand first. According to input output, which terminal is missing, that is your amplifier. It's a common emitter amplifier and there is a bypass. But common emitter amplifiers, we never write emitter top. Emitter has to be down, collector should be up. Then why can't you write this model in a neat manner again? If I write AC model for this correctly, it looks like this. This is Vs, this is 1K, this 10K will come down with ground. You bend this one to ground, and NPN, emitter you take down. Emitter bring it down, this one bring it down. You have a current of 10 milliamps with a capacitor here, CE, and top side we have 100 ohms with the ground. This is your output. So this is where correctly I am seeing your amplifier. This is collector and this is emitter. So now you can see clearly the model. Okay, this much work you have to understand first. The circuit properly I have written. Now you can see what is asking is the input resistance from the base. From the base means you have to calculate from here. RP is how much? Same from the base. So I know that for a common emitter bypass amplifier, for a common emitter bypass, your input impedance from the base, is equal to RPi. RPi is the answer. From the base if you want, it is RPi. From here if you want, it is 1K, 10K, everything will come. He's asking from the base. From the base if you want, you just leave this resistor, you leave this resistor, and tell after that what happens. Your answer is RPi is the answer. But RPi can be written as beta into RE. RPi is nothing but what? Beta RE. And whatever the current source he has given, indirectly this is nothing but your operating current. Already operating current diya, current source just indicate करके operating current diya. So the formula is beta into Vd by Ia cube. R is nothing but Vd by Ia cube. So how much beta is given in the problem? Note down it. It is 200. Beta is 200. Vd 25 millivolts you can take. Ia is 10 milliamps. Just solve this problem. How much is coming? Solve this answer. I think Raghavendra Pratap has given answers. 500 ohms will be the answer. Good. So I hope you are understanding the concepts. Okay. From the base, if you ask the input impedance of a common emitter bypass, we know is RPi. That will be the answer for it. 18th question is completed. Now 2021 we are doing. 2021. Today I am expecting BJT questions. I'll do it for you. When I know the BJT amplifiers correctly, how I am doing. Okay, MOSFET questions are easy and comfortable. Okay, that work you do it. BJT works, I'll complete it. Maybe hardly some remaining questions are left out for me. Around 7 to 8 questions are there. We'll finish and we'll stop the class. Okay. Otherwise, what I'll do is MOSFET amplifier questions. I'll take a separate video and I'll upload it afterwards. It's a recording video, not in the classroom. I'll just upload it as a recording video for tomorrow evening. I'll have some free time. I'll try to record it tomorrow or day after tomorrow. So and I'll also give solutions also for that in WhatsApp group. I'll send for you. Just see the solutions of MOSFET because it's not meaning that we have to solve both. BJT, if you know MOSFET, we can do it. Just I'll give the question numbers for you. Today you try the MOSFET questions. Tomorrow we'll see the answers if you want. Okay. At least BJT successfully we are completing each and every question. So question 18 ho gaya. Now question 20 try to understand. What is asking in question number 20? Let's see the question number 20. Satyam, if you're not able to catch these points, after the class you'll get a recording video on that. One by one, keep the workbook with you and try to solve it. Okay? At this point, simply write down the solutions if you're not understood. First write the solutions. Yeah, Majinder, definitely. Tomorrow I'll make a video for that. It's not a problem. Because evening 4:30 I'll be free. So after that I'll do that. Network चल रहे ना आपको? वो time में I'll record it. No problem. So in question number 17, why not Rx is 1 by Gm? Actually Rx is 1 by Gm only, question number 17 में. But option में देखा मैं, option में R pi also given. According to the option, I have written the answer for it. Okay? 1 by Gm only I can write. But option में he included R pi. That's why I've taken R pi also in the answer. Nothing more than that. So complete the 21st question in the problem. Complete the 20, 20 and 21st. 20 question I'm doing. CC. This is RE 1.5K. We have RC 6.8K. We have two resistors here, 56K and 8.2K. This is 22 volts and this is your output. So we have input and output current. Input and output current. So we have two currents. First of all, you think this is a bypass or unbypass? This is a straightforward problem. Bypass or unbypass? Current gain, I naught by II. You have to think that it's a common emitter bypass. In short notes already done the formulas. It is simply minus beta times these two resistors, that is RB by RB plus R pi. You'll solve this answer. How it's a matter of this formula. Without writing any modeling, a formula se khatam ho jayega. Beta into just RB by RB plus R pi. Just current division rule ka answer. Beta already given in the problem. RB is a combination of these two resistors. Here RB is nothing but a combination of 56K parallel to 8.2K, solve it. And R pi is nothing but here beta RE. It is beta times of VT by ICQ. Solve this answer from the passing circuit. You do it afterwards, these calculations. R pi you can calculate. R pi आप solve कर सकते हैं, RP solve कर सकते हैं. ये formula में find out करो, then you will get the current gain as, with this I'm getting around minus 72.3. ये answer आ जाना आपको. Just only formula base I completed. Okay? So just take the hint. You solve it afterwards after the class. Nicely solve this one. R pi is beta RE. Just RE passing circuit से solve करो. It's a voltage divided passing. Easily you can solve it. And EI minus 72.3 is coming or not? Just verify it. Okay? I'm having that answer with me. 72.3 something I got. That answer you must get. Coming to 21st question, if you see. Question number 21. It's a very good question. Very confusion for the student. RS is 10 ohms he has given. RE is given. It is 1 kilo ohm. Here he kept the capacitor. And here 5K, 33K, 11K, capacitor, out, input. He's asking you the voltage gain of the amplifier. So first tell me, seeing this circuit, can you tell it's a bypass amplifier or unbypass? Carefully see this diagram. It's looking like a bypass or unbypass. Give me your answers. For question number 21, I'm asking you, it's a bypass or unbypass? Come on, answer the question. It's a bypass or unbypass? Prashant Kumar, in the recording video, you can see all these things. Let me complete the solutions. Okay? Let me complete it first. The question का answers कभी भी देख सकते हैं आप. Okay? Classroom में waste नहीं करना time. Just listen the class and leave it. Afterwards, you can note on in the notes. No problem. So take free time and start practicing the questions afterwards. Just listen the class first. This is a bypass or unbypass? I'm asking you. This is an unbypass. Correct? Why it is unbypass is this resistor will become bypass, but this is unbypass. We have one more extra resistor. So first we'll do DC analysis for this. First we can do DC analysis to get some DC conditions. DC analysis look like this. 1.01K will be there here. This is 5K. This is 33K. This is 11K. This will be 12 volts. So you can see this is 11K, this is 33K, this is RS plus RE, this is 1K plus 10K, 10 ohms. C is open. So this total becomes here 1.01K as a voltage divided passing circuit. Okay, this is a DC passing circuit. The only thing you have to find is in the problem, base voltage find karo. Just find base voltage how much. After that you find the emitter voltage. You will get emitter voltage. Then find out the ICQ current. That is V by 1.01K. The answer solve karo. I'm not solving it. I'm telling the procedure for you. Base voltage find out karo. V find out karo. ICQ find out karo. You will get operating current in the circuit. When you know operating current, we can solve RE. VT by ICQ you can solve. ये भी आ जाएगा RE. So what is the gain formula for unbypass? We studied. Gain for unbypass. Common emitter unbypass. What is the formula is? It is minus GM into RC divided by 1 plus GM into RE. Here RE becomes RS. So this will become the RE for you. This will become the RE. Okay? ये short हो जाएगा. Only RS will be there. I think this is the problem. When I know this answer RE, can I find GM now from this? First I found VB, next VA, next operating current, next RE. Otherwise GM you can find directly. So GM you can solve here, which is 1 by RE. So if you get all these steps, the wrong steps you done for DC part, it is helping me to write the answer here. So this formula will solve it. So maybe the answer I have with me, minus 238.08 should be the answer. So this is about the 21st question. After the class, just one time solve this data and check that answer, minus 238.08. Right, one thing you remember, any amplifier question, Any amplified question cannot be solved without DC circuit. Please remember this point. If they give directly RPi, no problem. If they don't give RPi, they don't give beta RE, compulsory DC part. We have to do the steps like this because GM or RE come from DC circuits. Okay, every time you have to take a hobby for your calculations. First to do the DC analysis, get me GM first, then find out the gains automatically. Because GM come from DC analysis. This is the best example you can see. So question 23. Is there one more question? Question 23. So I'll stop at question number 23 now. Here I'll stop it. The remaining questions like T2, T3, T4, T5, T6, that questions will be coming in the next video for you. In your MOSFET, it will continue with these questions. Okay? Up to here, if I teach, you got a procedure how to solve the questions. The remaining questions are only basic questions. Only T2 question is somewhat interesting question that I'll show you in the recording video. In the next class, I'll present that video in your recording videos. Okay? So you get that solution extra for you. Then I'll make it recording and I'll send you. Up to here, please try to complete. Only one question is remaining extra. With that, I'll stop the class. Nearly at 5 o'clock, we are stopping today. Tomorrow at 8:30, we'll start the class. 8:30 to 4:30 is tomorrow class for me. After that, 5 to 8 or 8:30, network sir will take the class for you. Okay? That is the tomorrow time. The last question here. 23 question will be the final question for me. In the next video, it will come from there, the questions. Question number 23, with this I'll end up the concept today. He has given here 400 ohms. We have coupling capacitor, we have VI, we have resistors, biasing resistors, 1.9K and 9.1K, and we have transistor with 200 ohms, with some capacitor, with 300 ohms, 330 ohms, with 10 volts. So like this, he has given a question for you. He missed it to give the output here. Actually, collector side he has to take output. In the book it is missing. You take the output lines. 23rd question, last question, before try yourself. So, he's asking you, what is the value of 3 dB frequency F1 due to coupling capacitor C? Due to this coupling capacitor, what is EFL? He's asking. So we know this practice. If I want to solve this one, your model is like this. This is RS, this is RP, R equivalent, and here we have RPi. Okay? If I solve from here, R equivalent, we'll get it as RS plus RP parallel to RPi. This is R equivalent. So the formula will be FL is equal to 1 by 2 pi Cc, that is your input capacitance, into R equivalent, which is RS plus RP parallel to RPi. The complete data he has given in the problem. You have to just solve the answer. Okay? This is about the input frequency, FL, how to solve. So with this maximum tricks I have explained, each and every trick I explained. Okay? Who has not in the first manner I have done it. Maybe some students who has not getting confusion in some problems. You take the video slowly and listen to the class and try to do the problems. Okay? एक बार practice कर दीजिए after the class also. This video will be with you only. Understand how each technique I said, each problem का solution कैसे कर रहा हूँ. एक बार practice कर दीजिए, confidence automatically आ जाएगा problems में. Okay? So this answer I think I don't have with me. You have to propose what is this answer by yourself. इनका आंसर एक बार कैलकुलेट करके देखो. How much will come? It is 1 by 2 into 3.14 into, it is 20 microfarads into RS is 400 ohms plus RP. You have to take parallel combination here. RP is 9.1K parallel to 1.9K. You have to take parallel. Let us see how much this one. Please solve it parallelly. 9.1 into 1.9 divided by 9.1 plus 1.9. It is 3.8K is coming. 3.8K is coming. Is it correct? एक बार calculate करके देखो. Any mistake I am doing? 3.8K parallel to that RPi is how much given? Problem में RPi दिया हो 0.245K. 0.245K. So let us solve this answer and see how much it is FL. और try करो एक बार FL को. Just see how much answer is coming. With that we'll end up these concepts. We'll get 2 videos. This is part 1 you can consider. Part 2 will come as a second video with MOSFET practice also. Okay? So for the CE capacitor, how you calculate FL can use. We're drawing circuit. No, yeah, Parthasarthi, I'll not show any derivations. You straightforward seeing like this, you can find out the answers. Okay? आने के लिए कोई नहीं है. R equivalent means this network पे इसलिए हो. R equivalent directly आ जाएगा आपको. Derivation नहीं चाहिए. Unnecessarily don't waste your time in thinking the derivations. Okay? Okay? Some data को I have to compress it. Otherwise waste of time for you. Nobody will ask these derivations. But without knowing this formula, I cannot solve the questions. So formulas को आने के लिए trick है. I said a trick for you. RS plus RP parallel to RPi. Trick को understand करके आंसर निकालो. क्यों time waste कर रहे हो आप? Derivations से क्यों चाहिए आपको? Whenever I want derivations, wherever I want, I'm explaining that one. इधर नहीं चाहिए. Straightforward complete करो. RP is 1.57 आ रहा है आपको. I think I done some mistake. 1.57K. Sorry. 1.57K. Yes, I'm waiting for you. What is this FL? Please find out. Kamlesh has given 19.90H. Is it correct? Satyam is also telling 9.85. Yeah, 9.8, 9.85 H will take. Okay, around 19.85, 19.90 is okay. Okay, Akash, thank you, Akash. Thank you very much for your confidence you are getting. Somebody got different answer. 13.02 H. Sahu is getting 13.02. I think 19 ARA, 13 RA. Sanjay? Saudinya? 13 RA. I think 19.85 or 13. RP is 1.5K, FL is 13H. I think when you take this answer, it is coming 13. Yeah, you take 13H. Correct. 13H you can take the answer. Most of the students got 13H. Great. Majumdar, maybe our EC class will be completed by Friday here. We'll get a next part 2. We'll get this video as part 2. Part 2 video. I'll complete MOSFET also in that. Same style of questions. MOSFET I'll try to cover it as a recording video. Classroom I'll not teach you. Just you can watch the solution for that. Okay. Tomorrow I'll make that video for you. Part 2 video. So here I'm stopping. So tomorrow I think 8:30 to 4:30. Our main job is to complete the common collector amplifier and a common base amplifier. Tomorrow study. Similar